Hello to Time Value of Money Part 2. Now in this presentation we are going to cover the annuities. So our sole learning goal in this session is to find the future value of the present value of both an ordinary annuity and an annuity due, and find the present value of a perpetuity. So let's proceed. What is an annuity? Annuity is a stream of equal, so it's repeated, stream of equal periodic cash flows. So the amount is always equal and it is repeated. It is repeated over the number of years, months, or any other frequency. So these cash flows can be inflows of returns earned on investments or outflows of funds invested to earn future returns. Takes It can take both sides of the transaction. There are two types of it: an ordinary annuity and annuity due. An ordinary, or also called deferred annuity, is an annuity for which the cash flow occurs at the end of each period. As we discussed previously, under the timeline we write end of each period, or end of period, or end of year. So that we were so if we have to plot the annuity on the same timeline, it would refer to ordinary annuity. Ordinary due is different in that this is an annuity for which the cash flow occurs at the beginning of each period. So end could be, let's say if we have a year from January to December, so ordinary would be 31st December, while beginning would be 1st of January. So an annuity due will always be greater than an otherwise equivalent ordinary annuity, because interest will compound for an additional period. So we will see this in action later in this session. First, let's look at an example. KA is choosing which of two annuities to receive. Now, if you look at the characteristics, both are 5 years, 1000 annuities. So annuity A is an ordinary, annuity B is a due. And if you look at it, annuity A starts at year B, so it's the end of the year. For annuity A, it's the end of the year, and for annuity B, it's the beginning of the year. So it starts at the end of year 1000, 1000, 1000, and then so on, with a total of 5000. The other annuity also have 5000, but it starts at the beginning of the year. So it starts at 0, then at the year 1, year 2, at the year 3, year 4, and in year 5 there is no investment. It's a good practice if you want to differentiate between two annuities. Draw parallel lines, one for ordinary and one for annuity, like this. It's 0, 1, 2, 3, 4, 5. And so this is annuity, ordinary annuity. I just, for the time being, call it AO, and AD, let's say it's a deferred. So it will be the same timeline with 0, and if you plot these 1000s, they will be on this lines for AO, or ordinary annuity, year 1, year 2, year 3, year 4, and year 5. And for big annuity due, it will begin from this point and will go on these years, and 0 for this year, last year. So this is end of year and it's a beginning. Let's get the formula through which we can actually uh, calculate an ordinary annuity. An ordinary annuity has a formula of future value, which is number of n years, months, weeks, whichever the time period is. Then we have a cash flow, and that cash flow is what we call repeated amount that we uh, receive or invest. And then we have a multiplicative term of 1 plus r raised to the power n minus 1, and something like this. You get the brackets are a little bit misaligned, but this is what we have. Cash flow is the repeated equal amount, and it's in a dollar amount. R is the interest rate, as we saw in the last session. Then we have n is the time period. So we can get a future value. Always when you look at these formulas, you can see that if future value is given, cash flow is given, R is given, how to find n. So mostly it's you can use the plug-in method. We'll discuss this later. However, you can see that the unknowns could be anyone. Right now we are focusing on direct calculation of future value, but we can change the order and can find the unknowns as well. Let's move forward and calculate the value for the cause. So it's cause wish to determine how much money she will have at the end of 5 years if he chooses annuity A in the last to last slides, and the ordinary annuity, and it earns 7% annually. So we can use the same formula. We can see that it is future value n equals to cash flow one plus r raised to the power n minus 1. And we can keep r inside or outside, doesn't matter, it's a multiplicative term. So we have 5 years, which is n, 7% which is r, and it's annual, so we don't have to play with the variable anywhere, and it comes out to be 1000, which was the cash flow, and r is 7%, so we put 0.07, and then we have 1 plus r, 1 plus 0.07 raised to power n, which is 5 years, and then we have minus 1, and we will get a solution of an answer of 5750.4. But this is the future value. If it is if annuity is if option A is considered, which is the end of year ordinary annuity. Ordinary annuity means that the payments are or investment is always at the end of time period. Now let's look at the timeline. If I had to calculate without using the formula, then it's also possible. It's pretty much easier, and it also gives us some conceptual insights. For instance, in this case, we have 1000. It's a end of the year, so it's ordinary annuity. And ordinary annuity, the timeline starts with 0, but investment or saving starts with year 1 and all the way. So we have this end of year 1, end of year 2, and so on. This is end of year 5. So we invested $1000 at the end of year 1. Now, how much times it remained invested. So it remained invested for 1 year, then another year, then another year, and then another year. So that's 4 years. And after this, we don't invest anymore. So it stops. So fifth year is the end of the year, and it's also our end of the time period as well. So we do not invest here. So this means that we have n equals to 4 years. This comes here. So we can calculate the using the single payment formula. This 1000, treat 1000 as a single payment, and that would be future value then we have present value, which is 1000 multiplied by 1.0 1.07 raised to the power 4, and that will give us the value 1310.80. For the second amount, we can use n equals to 3. This is n equals to 2, this is n equals to 1, and this will be n equals to 0, which means this amount does not get any benefit of investment. No time value is applied on it, no TVM applied on it, and it stays the same. The total amount becomes 5750. However, you can see that this is a cumbersome process, and there could be certain mistakes that can be made. For instance, n is equal to 4, while on timeline it appears 5. Actually, it is 4 years, as we saw that at the end of the year it was invested for 1 year, 2, 3, 4, and the fifth year, actually at the end it was invested at the end of the fifth year, and it doesn't go forward, so no more time value of money is applied on it. The same calculation can be done through calculator, which is pretty much easy. The negative sign shows the cash outflow. PMT is the function that is used for equal payments and repeated equal payments, which is what we call annuity. And then we have N, which is 5 years old, then I, which is 7%. We press the compute, and future value we get 5750.74 thousand as a solution. Apart from that, in Excel you can do the same thing. You can apply the formula, or you can build your own formula, or you can use the formula from the bar and can calculate it, which is 5750.4. Now let's move on and look at the present value of an ordinary annuity. Present value of an ordinary annuity is calculated as such. So we have present value equals to the cash flow. So it looks like familiar because we did the same for the future value. And then we have 1 minus 1 over 1 plus r raised to the power n. This is our present value of the ordinary annuity. So cash flow we already know. This is the annuity. R is the interest rate. N is the number of time periods. Now with this formula, where we actually divide this term, if you see this term, we are dividing. In future value we were multiplying. So when we divide this, we are calculating present value. This is another way to remember it. Now let's look at an example. BCC, a small producer of plastic toys, wants to determine the most it should pay to purchase a particular annuity. The annuity consists of cash flows of $700 at the end of each year for 5 years. The firm requires the annuity to provide a minimum return of 8%. So this is R. $700 is the annuity, and we call it CF, cash flow, in the formula. And number of years or time period is 5 years. Let's use rewrite the same formula again. So it's present value N equals to cash flow divided by R, and it's 1 minus 1 over 1 plus R raised to power N, and that comes out to be equals to uh, $700 divided by 0.08, and then we have 1 minus 1 over 1.08 raised to power 5. This can give us an answer of 2,794.90. Let's look at the timeline. Timeline is a little bit different, and you can see again it's the end of the year, and so we have let's look at this one. So we have number of years given here, 0, 1, so it's the end of year 1, end of year 2, so on, and it's end of year 5, end of year 5. Now if you look at it, the annuity that you will receive at the end of 5th year will be, so the present value means that we'll look at the we'll bring it back to 4th year, from 4th to 3rd, from 3rd to 2nd, and from 2nd to 1st, and 1st to 0. 0 means it's today. So we always, when we are calculating present value, we bring the investment to today, or present, at present, whatever is the time right now. So you can see that 5 to 4 is 1 year, 2 years, 1 to 2, this is 3rd year, this is 4th year, and this is 5th year. So here we have N equals to 5 year, and if I have to calculate the present value for a single amount formula, I can use it present value equals to future value divided by 1 plus R, and that is N. That comes out to be 700 divided by 1.008, and this is 5, and the answer is 476.41. So this is 5 years discounting. Now for subsequently, we can also see that it is for 4 years, this will be 3 years, this will be 2 years, and this will be N is equal to 1, because the last payment will go only from 1 to 0 for today. So when we sum up all of them, and will total present value of 2794, which is exactly the one that we found using our formula. When using calculator, we will use the PMT function, which is annuity or cash flow. It's an annuity because in calculator there is another button for cash flow, so I don't want you to mix that with this PMT. And then we have N is equal to 5, I is equal to 8, compute, and you can press the present value, which will give you the same results. And same, you can do either build your own formula or use the pre-entered formula in Excel, and you can calculate it. You can have 2794.9 as a solution or answer the problem. Now let's look at the uh, future value of an annuity due. Annuity due has a little bit of a different formula, and we'll see why it is. So it is basically the same formula that we prepare for, we write for ordinary. So future value cash flow divided by R, and we have 1 plus R N minus 1, and then we just multiply one more time period, one more factor, 1 plus R. Now this is an additional amount, while we already know that this is the annuity CF, R is the interest rate, N is the time period, and 1 plus R is the additional time, additional one period added, one period factor added, factor multiplied. Now let's look at the example. It's the same example that we started at the beginning, where cost was comparing two investments of 1000, where we have the cash flow or annuity equals to 1000 and N equals to 5 years, and interest rate was 7%. Now the formula which we have for estimating the future value annuity is annuity due, CF over R, and then we have 1 plus R, and then since it's an annuity due, we're going to multiply by 1 plus R, an additional factor. Now when we do this, we will have 1000 0.07 multiplied by 1.07, and that's raised to power 5 minus 1, and then we have multiplied by 1.07, and that will give us the answer of $6 153.29. This is the future value of annuity due. So this is future value of annuity due. Now let's look at the timeline of the same problem. The timeline has a few things that we need to discuss before we move into in a bit more detail. First, you can see clearly that this is beginning of the year problem. It's a due, and whenever there is the annuity due, so this will be the beginning year problem. Now beginning means that it starts from the zero, from year 0. If it starts from 0 and we have 5 years, then eventually it will end at year 4. So if if we assume this is the first, so 0 is today, we invested 1000 today, we have only 5 cash flows to invest. So at the beginning of next year, so this will be beginning of year 1, this is beginning of year 2, beginning of year 3, beginning of year 4, and finally beginning of year 5. So beginning of year 1, we will invest another 1000. Beginning of year 2, we'll invest another 1000, and so on till beginning of year 4 we'll invest. Now by 4, if you calculate, we have 1, 2, 3, 4, 5 cash flows. We had only 5 cash flows in the question, which ended at which the last of which we have invested at the beginning of year 4. Now we see what happens here. Now we have to compute the N. N is, if you know the N for a single amount, you'll be able to compute this problem. So if you see this 0 and 1000 invested at time 0 will be invested for 1 year, then second, so I'll write 1, 2, then 3, then 4, and then 5. So time period is 5, while investment at the beginning of year 4 is the last one, which will also remain invested for 1 year. And we are going to compute everything at the year 5. We're going to compute everything at year 5. So for this, we have now 5, and for this 4, 3, 2, 1. So all investment, the last investment was invested for only 1 year. So if we take the single payment formula, we can calculate the present value um, of the future value of the annuity, which is future value will be future value equals to present value multiplied by 1 plus Rn. And for this we have 1000 multiplied by 1.07 raised to power 5, and you will get this value. When you make it 4, it will be this value. You repeat the same formula for this with n is equal to 4, then the same formula for this, n is equal to 3, n is equal to 2, and then n is equal to 1. The same formula, just change the n and you will get all these values. When you add all these values, you will get 6153.29 future value. Now let's look at the other tools to compute the same example. If you're using calculator, you have again use PMT, which denotes the annuity, and minus means cash outflow. So n is equal to 5, interest rate is 7%, press compute, and then you will have future value. Remember to clear the calculator, always clear the calculator memory so that the old values does not uh, uh, create any problem for the new with the new values. Also, you can see that you can calculate by using a future value formula, and you can get this, or you can structure your own formula and enter the inputs, and you can get these are the inputs, and you can get the answer 6153.29. Now with the example we did, the $1,000 invested at 7% for 5 years. Now this is the information that we had, and we have been able to calculate ordinary annuity this and the annuity due this, and you can see that future value of ordinary annuity is less than this. So this will be always, future value of annuity due will always be greater than the future value of annuity, ordinary annuity. It is because there is an additional 1 plus R factor multiplied, which means there is one more year the last investment remain invested in the timeline, or in the as per TVM. Now let's look at the present value of annuity due. Present value of annuity due is the same formula that we use, and that is present value of annuity, and we have cash flow over R 1 minus 1 over 1 plus R factor. Remember, we always divide it. When there is a division, there is a present value. When there is multiplication, there will be future value. And then there is a term 1 plus R that is multiplied further. Now this is multiplied, not divide. 1 plus R is multiplied, which makes it an annuity due. So this is now the factor that actually differentiated from the normal factor. This was the normal formula for ordinary, and by multiplying with 1 plus R, it becomes an due annuity, or annuity due. Let's look at another example. In this example, we have or we assume that we have a cash flow of $700. We have interest rate which is equal to 8%, and we have n, or time period, equals to 5 years. Now calculate the present value of annuity. Present value of annuity due. So it is annuity due problem. In this, we are going to use the earlier formula for present value of annuity, which is present value of annuity equals to cash flow over R, and then we have 1 minus 1 over 1 plus R n, and then since it's a due, so we are going to multiply the interest rate factor, one more interest rate factor. Substituting the values, we get 700 divided by the 0.08 multiplied by 1 minus 1 over 1.08, and that's and the additional factor that we multiplied due to annuity due problem, and this is 1.08, and the answer that comes out to be 3018.49. This is the value that we get, the present value of annuity due. We can also calculate it from the other sources or using other tools, for instance calculator, but for that you have to understand that you have to switch the calculator to beginning mode. In the beginning mode, after beginning mode, the rest of the operation is the same as we used to do it in the ordinary one. PMT is the annuity, which is 700, N is 5, I is 8, and we compute and we get compute present value. Solution is minus 3018.49. Similarly, we can do it for the calculator and the through the formula, or build the formula and insert the inputs, and we get the 3018.49 formula is the output. Now, after going through annuity, in which we have done two types, annuity, ordinary annuity and annuity due. Within ordinary annuity, we have gone through two important concepts: present value of annuity, future value of annuity. And in annuity due also we have gone through present value of annuity due and future value of annuity due. Now now we go and study perpetuity. Perpetuity is, as it says, forever. We assume that the time period is infinite. It will go on forever. So a perpetuity is an annuity with an infinite life, providing continual annual cash flows. If a perpetuity pays an annual cash flow of CF starting 1 year from now, the present value of the cash flow stream is, then it would be present value of perpetuity equals to, you have a cash flow divided by the R. As simple as it. So we used to do something in the annuity when we used to calculate the present value, which was 1 minus 1 over 1 plus R n, and so on so forth. This term, entire term, is gone because of t is equal to, or n is equal to infinity. Once n is equal to approaches infinity, this becomes negligibly small. We are left with this term, which we use as perpetuity. Let's look at an example. RC wishes to endow a chair in finance at his alma mater. The university indicated that it requires $200 per year to support the chair, and the endowment would earn 10% per year. To determine the amount RC must give the university to fund the chair, we must determine the present value of 200, perpetually discounted at 10%. So this is basically the cash flow forever. So it will go on forever and forever, and time, this is the R discount. So we have present value equals to $200,000 divided by the R, which is 10%, so it will be 0.1, and that comes out to be $2 million. So in this session we have studied the third learning goal, that is to find future value and present value of both an ordinary and annuity and an annuity due, and find the present value of perpetuity. And that's what we have done. For ordinary annuity, we know that It's a straightforward formulas where there is no additional factor. And annuity due, we have 1 plus r that is multiplied to both present and future value um, in order to take into account one extra time period that is part of annuity due. Also, we know that this is always beginning of the year and this is end of the beginning of, and this ordinary is always end of year. So thank you very much, and let's look forward to present the mixed stream and mixed stream problems. Thank you.